A new robotic camera at Palomar Observatory is scanning the night sky to capture some of the most volatile and violent events in the universe, including stellar explosions and colliding neutron stars. The device is the linchpin of a program called the Zwicky Transient Facility, which updates one of the observatory's telescopes in order to shoot images of the cosmos in motion. It will scan the sky nightly, looking for changes in movement or brightness. Those could be passing objects such as asteroids or comets, or rarer phenomena, such as the momentary flare of a dying star. The Zwicky is celestial cinematography, which is an order of magnitude faster than anything before, said Mansi Kaslewal, assistant professor of astronomy at Caltech, who leads some of the science programs at the observatory. It's looking for very rare, very fast, very young events. I'm excited. I think it will be a lot of fun. In November, the camera shot its first images, a milestone astronomers call first light. The program, named for pioneering Caltech astrophysicist Fritz Zwicky, who discovered 120 supernovas over his lifetime, places Palomar at the center of a network of observatories across the globe. It's an $18 million investment, funded through a $9 million grant from the National Science Foundation, and matching funds from participating universities, said Srinivas Kilkarni, the principal investigator of the facility and a professor of astronomy and planetary science at Caltech. Partners include Caltech and the University of Maryland, University of Wisconsin, University of Washington, Seattle, and institutions in Taiwan, Israel, Germany and Sweden, along with help from the Department of Energy laboratories at Los Alamos and Berkeley. This is very large, Kilkarni said. Is a global effort. And it's based right here at Palomar. The new camera sits inside a 48-inch telescope, one of 3 at the observatory, along with 60-inch and 200-inch instruments. Last week, Caltech engineer Michael Feeney worked on the device with mechanics from the observatory. Clad in white suits and hair nets to minimize dust and debris in the sensitive apparatus, they installed black baffles to absorb stray light within the telescope and prevent reflections and ghosting. Caltech engineer Michael Feeney, left, along with Mark Thompson, and John Derek Knapp work inside the Samuel Oskin telescope, where a camera was installed as part of a new automated sky survey project called the Zwicky Transient Facility at Caltech's Palomar Observatory KC. Alfred, the 576-megapixel camera contains a mosaic of 16 sensors that work together to automatically record cosmic images. It illustrates the evolution in astronomical technology since Palomar Observatory was dedicated 70 years ago in 1948, Feeney said. When this was first built, they used photographic plates, and the image was burned into the chemicals in the plate, he said. When all is said and done, this will be a robotically driven instrument. You basically press go and wait for the data to come in. We're very happy with resolution, the quality. It's just incredible. The new camera will scan the sky over the course of 3 nights, and then repeat the survey to detect differences between the images that suggest movement or changes, Feeney said. It also scrutinizes specific portions of the sky in greater detail to search for those transient events, Kilkarni said. A suite of computers analyze those results in real time. If they reveal something of interest, within minutes the system will alert large telescopes around the world, said Roger Smith, the lead engineer for the camera. They need a discovery engine to tell them where to look, Smith said. We provide an all-sky surveillance to find anything that moves or changes in brightness. The images will include binary star systems, in which 2 stars dance in orbit together and periodically eclipse each other. Those events can help astronomers study the geometry and mass of those systems, Kilkarni said. It will also search for supernovae, the catastrophic explosions of dying stars that blaze suddenly and then fade over days or weeks, allowing the camera to pick them out of the background light, the very violent events. Kaslewal said. They can only sustain that luminosity, that brightness for a short amount of time. In the nuclear furnaces of those dying stars, heavier elements form as smaller atoms crash together. The stars are actually fusion reactors, Kilkarni said. By studying supernovae, astronomers are studying how the periodic table got put together. Astronomers will also look for changes in neutron stars, extraordinarily dense, collapsed stars that produce the heaviest elements. The collision of 2 neutron stars, or a neutron star with a black hole, can give you a flash of light that is 100 million times the brightness of the sun, which the Zwicky project aims to detect, Kaslewal said. Neutron stars are the cosmic mines of heavy element production, where the heavy elements are created: gold, platinum and uranium, silver, neodymium, she said. About 130 elements on the periodic table heavier than iron are synthesized in such extremely violent conditions. Understanding how rare metals are created helps explain the origins of matter in the universe, researchers said. People wear gold and platinum wedding rings, and they take it for granted that gold is present on Earth, but it had to be made somewhere, and it's made in neutron stars. Castlewell said. It's satiating the scientific curiosity to know where the elements around us come from. Sorting through the vast troves of data also has immediate practical applications, Kilcarney said. Students who work on these systems become experts in handling large datasets, he said, and some move on to jobs with tech companies such as Google or Amazon, which rely on that type of real-time analysis. Although larger telescopes such as the Keck Observatory in Hawaii are in greater demand than those in San Diego, Castlewell said Palomar Observatory allows researchers to log more time on long-term projects that could lead to groundbreaking discoveries. There have been entirely new frontiers in astronomy at Palomar that have opened up because people have asked bold questions and undertaken systematic campaigns to look at the universe in creative new ways, she said. I have used telescopes at many mountaintops in the world, but by far my favorite mountaintop is Palomar. Deborah.Brennan at SDunionTribune.com, Twitter at DeborahsBrennan.